Hey, in this video we're gonna have a look at some Redshift render settings and how to optimize them. So this was the render we had. So one first thing real quick is I'm gonna create a network box for the lighting, just to clean the scene a little bit. And also I'm gonna crank up the key light a little, like a multiplier around 6 might work, just to give some extra punch on the key light. So I'm gonna use the crop window, and it looks like it could work a little bit better, I think. Some nice contrast and stuff, so yeah, that will do. Okay, one other thing is the fiber shader. I'm gonna increase the radius of the SSS a little, like 0.04. I think in that case it would work a bit better. So it's a bit more diffused inside those fibers. I kinda like it. Better. Let's compare before, after. Yeah, sure, why not? So in the render settings, we're gonna go inside the volume and we're gonna play a bit with it. I'm not sure we're gonna end up using it, but it's always interesting to play with. So let's go inside the light. You might need to crank up contribution scale to enable the volume of this light. And we are getting this smoky vibe. So in this situation, it's not super useful like for Lighting Studio, but if you want to do like some kind of smoky effects or stuff like that, it could be an interesting way to start. So we could try to play with the difference of contribution. In that case, I'm reducing the key light's contribution so that we mainly have the blue light. So the blue light fog is taking over the key light, so that's pretty interesting in terms of colors. Also, sometimes tweaking the attenuation can get some interesting results, mostly because it allows the light to fade while scattering inside this volume. Also, we have the scattering. Well, the higher the values, the more opaque is gonna be the volume. So usually I tend to leave it with a very low value. All right. So that's pretty nice, but in this case, it's not bringing anything that we couldn't do in comp. So I might disable it and we'll see how we can achieve that in comp later. So you could get more interesting result by plugging a texture into the light, of course. This would give different values across your rust light and would help breaking up the volume. If you are interested, feel free to play more, but on my hand, since it's gonna increase the render times quite a bit, I'm just gonna leave it off for this tutorial. So back into the global illumination settings, in part 7 we set everything as a brute force render, which means Redshift is literally shooting rays anywhere into the frame, which can be fine as a primary engine, but a secondary one can tend to get very blotchy result unless we crank up the GI rays like a lot more. So I'd rather have no secondary GI than using brute force, really. So with this render, it doesn't look too different from what we had, maybe a little more contrasty without secondary GI, but that's fine. One thing to make sure before going further is make sure that you have automatic memory management enabled. This is basically taking care of all those sliders for you, which represent how Redshift is allocating your GPU for different tasks such as loading texture, cache, GI. You can always manually control those by disabling this option, but personally, I wouldn't take any risk. Now, inside optimization setting, you could crank up a bit the max trace depth of reflection and refraction. This allows us to define the number of times a ray can cross a refractive surface. Since we actually have quite a bit of crystals, we should increase these values to something like 8 to be safe. Redshift documentation gives some great example how these settings affect your scenes, so you could have a look at that if you're not sure about it. In our case, those rays will be absorbed by the refraction extension of our crystal shader, so we could get away with lower values than 16. So value of 10 for refraction, even less, would work, and 6 for reflection would be way enough. So back into the GI settings, we're gonna experiment with other engine. Just before that, let's enable the bucket rendering and the crop region so that it doesn't take forever to wait our renders. So my previous settings for bucket rendering were fairly high. We're gonna start back with lower sampling, like 1 to 20 samples. So render it's done, it's pretty sweet. Gonna snapshot that. It took 40 seconds to render. Now I'm gonna change the primary engine to Irradiance cache. So what's the difference, you're gonna ask? We can notice this weird looking prepass starting. Irradiance and point cloud cache is like a cache of tons of little previews or samples of GI if you want. And what it does, it computes the sample and averages the GI by doing interpolations between those samples. So it tends to work better on flat surface and simple shapes. If you got very intricate geometry where you need a lot of details on how the light bounce, you should go brute force for sure. So the render finished, and we can see it looks way longer, 3 minutes against 40 seconds for brute force. But mostly because we haven't touched any settings yet. We can notice that the render looks much cleaner though, especially in the back, since the solver is basically blending every samples together. Now we have this min rate and max rate to take into account. This is indicating to redshift the minimum and maximum resolution to sample the GI. A value of -1 is actually dividing the picture by 2. In this case, 2080 pixel would result into a maximum resolution of 640, while -3 as a minimum will cache a resolution 4 times lower, so 320 pixel. Also, our number of rays is pretty high. At this point it's more than our brute force. So we're gonna first reduce to 200 rays. We dropped render times at 54 seconds without visible changes. We could try and lower the number of rays even more, like around 100. And to save some more rendering times, we're gonna uncheck show calculations. So we end up with a rendering time of 51 seconds for this render. It's not much more than the brute force, but looks way better. Now we could try and apply some secondary GI. No brute force, of course. Let's go with Irradiance Point Cloud. Same deal than Irradiance caching, we are having a pre-calc phase. In terms of setting, I would mostly change screen radius, which is the size of the area to sample. So the render's done in 1 minute 80 seconds, which is a tiny bit longer than before, but we have a bit of extra bounce and could end up being a more realistic feature, so I'm gonna try to keep it. Let's see with the full image now. So it took 5 minutes to render everything, which is pretty fast, but it's still very noisy, and we're gonna increase the samples then. Alright, this one took 10 minutes with a max of 120 samples. If we compare, it still looks kinda noisy, but we should definitely shoot more samples, like 230. This render took 16 minutes on my laptop. It looks already much better. I think we'll increase the sampling a bit more for the final render. Also, we are not rendering in full HD yet, so let's go into the main tab. Make sure the camera is properly applied into render camera, and let's override the camera resolution. We're gonna specify a custom resolution and set 1920 by 1080. In output, let's define a proper name. Gonna replace that by Fibrous Malachite Render A1. So we are exporting an EXR, of course, and it's 16 bits. So we'll see in the next video how to set up the AOVs.